Alright, so you already learned about classes and how to use classes in Python. You already tried them out yourself. You already used them in a real situation, building a Python script. So let's talk about one more concept that extends this principle of do not repeat yourself. So class inheritance, what is that? That's another way in object-oriented programming that lets you do not repeat yourself. It lets you reuse the code that you already have in another class through inheritance. Basically means that you can create a subclass and inherit functionality from parent class or from base class. And essentially this can let you leverage existing code in another class without doing copy paste, which is obviously something that we don't want to do if we think about do not repeat yourself principle. If we talk about object-oriented programming, it would not make sense if Python would not support inheritance. It's definitely something that Python supports, and I use it all the time, and you will see how class inheritance is used in frameworks and libraries. You have to know about this topic to understand how libraries are built and how you can build your own projects. So before you can understand how Python inheritance, class inheritance works, you have to understand what is inheritance. And the easiest way to understand this is by looking at the real situation in the world. We can think of child inheriting certain traits from their parents. For example, if you just look at yourself and your parents, probably you are already aware that you are inheriting hate from your parents or eye color. You probably have already noticed that in yourself, or even personality traits and so on and so forth. That's how it works in real life. That's the easiest comparison that I can do, comparing you to your parents. And keeping this idea in your mind, let's quickly go to Python code and explain the same concept with Python code. So classes called child classes or subclasses inherit methods and variables from parent classes or base classes. If we quickly would type out this concept in Python code, we would end up with this code that's in the screenshot here. We would have a class called parent that has some kind of attributes or class variables, for example, last name, height, eye color, and the child class will inherit from the parent class. And the inheritance happens here in parentheses. When you're defining the child class, what you're doing is in parentheses, you're just using the parent class, the name of the parent class or the actual parent class, the blueprint of the parent class. In PyCharm, if you just check the parentheses when using child class, you can see that in a child class we don't do anything else. We're just using pass keyword to not get any errors. But if you would check parentheses of the child class, it tells you that child class also accepts last name here, height here, and eye color. The same things defined in a parent class. So you can already see how you can reuse a parent class in a child class. And that's essentially the whole concept of class inheritance. About the specifics of inheritance, I already mentioned that because child class is inheriting from the parent, child can reuse the code of parent class. So this lets you use existing class to create a new class instead of creating it from scratch, instead of copy pasting code. And child class can acquire all the properties and can access all the data that's stored in a parent class. Through, of course, specific methods and ways how to do that, I will explain as we move forward. And child class not only can reuse the parent class, but it can also extend the parent class. So you can extend the parent class, or you can also modify and make it child class act slightly different from how the parent class acts without affecting the parent class. When you use class inheritance, you have this relationship between the child class and a parent class. And quick visual example of that is this diagram. I already explained these concepts, but keep in mind that also the parent class can be sometimes called superclass, And there is a specific reason for that you will see later in this video, in this document. So keep in mind that the parent class, it can be the base class, it can be super class, it can be parent class. There are multiple names for this type of class. And anything that uses the parent class, or for example person class, would be called a child class or subclass, something that uses the parent class. I don't think there's a point in me copy pasting this code example and showing you the output. It's pretty obvious here. We have a parent class, we have a child class, and if I would want to define a child object, obviously I can use these attributes that are defined in parent class. And if we would print this out, if we would execute this code, this is the result that we would get. Printing child last name, child height, child eye color. So let's keep on building on this concept and let's talk about parent class separately, or base class. When you think about parent class, you have to think about this class as a pattern out of which a child class or subclasses can be based on. But this is not always necessary. So sometimes you work on something and you just feel the need of using a Python class. So you come up with a class, you just add some class methods into the class, you work on things that you need to work on, but it's not obvious to you that this is going to be the parent class, and it's totally fine. You can't predict all these things as you're writing code. Sometimes you can, but a lot of times you don't even know that this is going to be the parent class, so just don't overthink this. Keep working on your code using class as it is, but understand that later, if you see that another class could reuse this code, then you can start to think about creating a pattern and trying to separate what should be in a parent class and what should be in a child class. The main idea here is to avoid copy pasting code between multiple classes. The idea is to have the code definition in one class, which would be the parent class, and then come up with new child classes or subclasses that could extend or reuse the parent class code. So this leads us to understanding that any class can be a parent class. It all depends on the context, on the situation that you're working on. So parent classes are not just random templates, they're just functional classes, Python classes, but the ones that you could extend or reuse if necessary. And a good example of that would be if we would say we have a general Python class called bank account, which we would assume that this is a parent class, but we understand that bank accounts can have multiple types. And for example, the typical types would be personal account and business account. And these would be the child classes of bank account. Many of the methods that are used in personal and business accounts would be similar. So you would not want to copy paste them between two classes. You would want to define the similar functionality in bank account and reuse it in personal and business account. For example, withdraw and deposit money, those are the same methods that are going to be used for both classes, personal and business account. Both of them are going to use these methods, so obviously you can do these methods in bank account class. And since business account is different from personal account, it could also have some specific methods that would only make sense to be used for a business account, not a personal account. Like perhaps a way to collect business records, forms, and etc. So let's take a look at this example. And if you don't have module 5 package, create one. Module 5. And in here, create a new Python package called class inheritance. And in this package, let's create a new file called example. So in the example file, let's define a new class. This can be copy pasted since it's very obvious. There's nothing new. You should already know and be aware of how classes work. What I would do here is I would add, of course, type hints, but just for this example, it's not that important. typing optional. So these would be my methods for a bank account. So now what I need to do is just add 2 more child classes, one of them personal account. Simply using the parent class name here would also give me these 2 methods in a personal account class. The same way I would define business account class, but like I said, let's assume that business class has to be extended with business functionality. You would do init method, or you could take the init method from bank account here, copy that, paste it here just to start to think about business account and what you want to do for business account. I would just copy that and start to think, what do I need to do for a business account? And let's say I know that there is something about employee identification number that I need to do. So I would update my init method to have another variable, employee identification number. It seems that we want to set it to some kind of string. So I would add a type string, but it's typing optional because it's none by default. Okay, so I would know that this is my init method. You can also see that PyCharm is already suggesting that there needs to be a call to a superclass, and it also gives you an option to add a superclass. I haven't talked about superclasses yet, or this method super, but we are going to talk about it at the end of this document. Just bear with me as I'm trying to explain this example to you. All you need to understand now is that if I don't want to copy paste, if I don't want to override or copy paste the bank account init method, like they're almost the same, and technically I don't need to define this self balance line 35 here. It's already defined in a bank account. So how I could have achieved this is by using super. So I don't want to explain super right now at this moment with this example, because I'm going to do that a bit later in this video and this document. So you will understand what is super, but I can't really explain it to you right now with this code. How you should understand super works is that super lets you access parent class, which would be bank account in this case. It lets you reuse. When I started this point, I wanted to reuse init method. So if I would want to use init method from the parent class, what I would have to do is I would simply have to do init and pass the balance into it, because balance is the first argument here. And what would that do? Imagine that super here equals bank account class. Essentially, this is the same as doing bank account init. Why do you need to use the super class? I'm going to talk about that later, and there are benefits of using super class, but just for now, for this moment, understand that to access the parent class methods, for example the init one, you need to use super function. And how else you would understand this is by clicking on this. It drags you to here, but also you could use a breakpoint here and just tell yourself that this is, with a print you can tell yourself that this is init method of bank account. So if I would run this code now, only have this definition. I'm never calling bank account class. So if I run this and I call business account, you see the output comes from bank account. So I am executing this method. And if I would add here print after business account, after super init, let's say I want to stop at this point and recheck what happened. And let's also do before, stop at 2 points. Let's run it again. So this is before. I have self, which is business account object, this one. And the whole idea that I wanted to do here is define balance attribute, which is defined already here. So if I would want to define the same balance attribute in business account, remember we are at this point now, we are stopped here. I don't have balance yet. That's why if I type self-balance, it says attribute error, business account object has no attribute balance. Not defined here yet. But if I call this method, let's do that, let's continue. This is already inside bank account init. Let's continue one more time. Now this is after calling super init. If I type now self balance, or let's check self first. Self, this is business account, of course. Self balance 0. It returns something because the balance attribute is now defined. So I hope this makes sense. This is how you can reuse methods from the parent class and extend them. And obviously for this example, what we wanted to do is have the balance, but also extend it with business related attributes. For example, employee identification number, business records, forms, so on and so forth. The attributes that would not exist in a bank account class. I pretty much already explained the whole essence of using class inheritance, but let's keep going. And obviously this line is not necessary anymore because the balance attribute is already defined by the parent class. And then obviously you could do the usage here. Let's say for personal account, of course I don't have these methods, but if I would have these methods in a business account, you can see that these methods would exist for a business account, but I would try to do them for a personal account. Obviously they are not going to exist. You would see unresolved attribute reference for class personal account does not exist because this method is only defined now in the business account class. And a similar thing would happen if we would take another example. Let's say we have animal class, and then snake would extend the animal class and add some snake related methods. It would be the same idea, and these two examples with bank account and animals should give you enough to understand how the relationship between parent class and child class works. So let's create a new file fish.py inside class inheritance. And inside fish.py, let's define a new class fish, and let's also add two methods for fish. Like imagine we can have different types of fish, but most of them can't swim and most of them can swim backwards. So with this in mind, we know that every fish or specific fish that we are going to define will be able to swim backwards. And this class fish, you would have to understand that this is a parent class, and we would definitely extend this class for any child classes. So let's talk about building a child class based on the fish class. I already touched on this topic, but I understand that child class can be a subclass and it can be derived class, which basically is class that inherits from a parent class. So this fish, it's a parent class. And inheritance happens in this way. If we compare these Python classes to biology, father, mother, and son relationship. Son inherits traits from the father and the mother. Same thing happens here with Python classes. Any child class that we will have here will inherit swim method and swim backwards method. So for example, if we would have a goldfish class as a child, we don't need to define swim method anymore. It already exists. The goldfish is inheriting traits from the fish parent class. And if I would run this code, it should work, but it doesn't because I'm missing one part. So in this example, we don't have init method, but obviously I have them here. First name, golden, or we could say gold. Last name by default is fish. Let's try to run it again. The fish is swimming. So goldfish is swimming. Perfect. And you can see that I don't have the swim method in goldfish, but I can use it because the parent class has it. This simply lets you understand that we can think of each child class as being a class of a parent class. So goldfish is a class of a fish class. So let's move forward and talk about child classes. we define a new child class throat without the pass keyword. See what happens. I have this text here saying indent expected. I do an indent. What happens then? Indent expected. Why does that happen? Well, you can't really, this is not the way you define classes in Python. There has to be something under the class. But sometimes when you're using class inheritance and you have everything defined already in a fish class or parent class, so you simply have to use pass keyword. And this would let you execute the code. Nothing is going to happen here because I'm not doing anything, but it just lets you execute the code. If I would remove that, it doesn't work. You get syntax error because that's not proper syntax. So that's one key thing to remember. And obviously if we use pass keyword, all the things that are defined in fish class are available without these two. Terry fish, the fish is swimming, fish can swim backwards, all the methods available. And it seems that I'm missing something from here. We could just add these two as well. For the fish, then the whole example would work. So let's build on top of this existing example here, and let's define a clownfish. Clownfish here, and let me comment all the Terry stuff. So again, we are using fish parent class, but what we are doing is we're adding another method to clownfish, which is only specific to clownfish. And let's create the object of a clownfish. Let's call it Casey. And obviously if we execute this code, Casey is going to have his first name, last name, because it all comes from the fish parent class, and he will have the ability to swim and live with, I can't spell this, and live with something in an ocean or coexist with something in a sea. So let's run this code. Works perfect. But how you can see the difference between clownfish and, for example, Terry here is that Terry is not going to be able to, PyCharm doesn't even suggest this method for Terry because unresolved attribute reference for class throat does not exist, because this method is only defined for the clownfish. So that's the difference. If I would run this, it's not going to work. We are going to get attribute error. Throat object has no attribute, but Casey or clownfish class has this attribute. And this obviously lets you separate things between child classes. All of the child classes can use one parent, but can have differences between each other. So Terry and Casey are different from one another just because of this method. They're similar, but they are not the same. So another thing that I have to mention to you is overriding parent methods. How can you do that, and why you should do that, and when you should do that? So far you saw me doing something with a child class and let it use a pass keyword to inherit all of the parent class fish behaviors. And also you saw me using a clownfish class that inherited all the parent class behaviors, but also created its own unique method that is specific to the child class itself, clownfish. We did that here with this method. That's all fine and good and should be clear by now, but sometimes you want to make a use of some of the parent class behaviors, but not all of them. And sometimes you just want to ignore something that's coming from the parent class. So how could you do that? When you want to change the behavior of the parent class in a child class, what you do is you override methods or attributes of the parent class. And you do that in a child class. But again, here you have to keep in mind that your program has to be designed in a way that overriding methods does not produce unnecessary and redundant code. You have to have the common sense, and you have to be smart enough to realize that the goal is to make your code be more efficient not the other way around. So sometimes overriding methods does make sense, but sometimes it won't make sense. And you have to be able to differentiate between these situations. And how could I demonstrate this is by just using a very simple example. Another child class, shark, which would use fish as the parent class. So let's do that. Let's set up that code. Simply we can take this shark class and as an example, I'm going to comment for now clownfish and paste it here. So let's split the whole screen and compare shark with the parent class fish. Now let's think about this for a second. We comment everything else so that it doesn't mess up the output. So what do we have here? We have almost the same type of init method, but there are a couple of differences. So skeleton for shark is different, so we override it with this value. We have eyelids, so we change the boolean value of this argument as well. So that's the difference. The shark is able to swim, so we have the same method. It's not visible here, but we are inheriting it from the fish. It stays the same way. But what we are doing here is we are overriding swim backwards method. So you can see that it exists in fish, but if the method would be different for shark, what I would have to do is just define a method with the same name, and this would override it. One more key thing is here that you probably noticed is that it's saying, the init method is saying here, call to init of superclass is missed. And if you see such things, you can try to add superclass. So yeah, adding a super function call here and passing in these values without overriding the init method seems to be the correct way to do things. Because if you don't do that, PyCharm suggests you that you need to have the call to init method of superclass, because otherwise you're simply you are overriding the original init method which comes from the fish. And why is PyCharm giving you this suggestion? I guess my best guess here is that you should be following the pattern or program design of fish, because you are using this parent class here. So that's why it's using this suggestion. So for you, whenever you see such suggestions, I would encourage you to do what PyCharm suggests you to do, because you are new to this and PyCharm is very likely suggesting correct things to you. So let's go with that approach and let's use super method and let's ignore all of these things. The approach that PyCharm suggested using super function is the same as I would do this. If I would just ignore super and I would directly override init method, the same thing would happen if I simply use super function. Maybe it's not obvious to you yet, but those two approaches would give you the same result. Let's actually see how does that change things. Let's take this last part, let's create a Sammy shark and let's print first name and all these things. Let's run the code and see what happens. So you see I have Sammy as the first name, that should be here first name, and then I have shark as the last name because we are overriding the initial init method which comes from fish. We're not using last name fish anymore as the default one. We are using shark as the default one, and we are doing the same thing for skeleton. We are using a different name for skeleton and eyelids. We are still using the fish pattern or the fish class design. By calling super, we are executing fish init. This is what happens here. And obviously, if I'm doing fish init and I'm using shark from here as the default one, it's going to be passed into the fish. And if we go into the fish, last name here is already shark. We could see that with a breakpoint. How I like to do it is when I don't understand things is I just print them out and stop with the breakpoint simply. Let's run this code again. fish, last name shark. See, as long as you understand the flow of execution, you should be able to do prints and breakpoints and see what happens. So you're overriding the original init method and you're passing in the values that you want to see for the shark. That's pretty much how it works. I talk about all these points here. I'm just not mentioning super function call here because the other way also works. It's just that this seems to be more correct way, but the result would be the same. And we could see that if I would just comment this and use the same approach and ignore the suggestion here, it would happen the same way. It's just that it's slightly incorrect because you're not following the pattern of the fish class, but it's slightly incorrect. It's not totally incorrect. See, if I run this now, had the same result as before. So that's pretty much how it works. It's just that using the super function is the correct way, or more appropriate way of changing a child class behaviors. And finally, we're here to talk about super function. I already showed you a couple of times in this video how to work with super function, and you are already slightly familiar with super function, but let's talk about it deeply and why this function even exists and why you should know about it. Super function gives you the access to inherited methods that have been overwritten in a class object. So you just saw me doing that with init method here. Technically, in a shark class, which is a child class, we are overriding init method that's originally defined in fish here. So at the moment when you define a new init method, like method with the same name as in parent class in fish, at that moment you are overriding the original method that comes from fish. But sometimes you still want to have the access to the parent method to reuse the functionality that's already defined in the parent class. For example, in this case, the functionality is that we are defining these attributes, but it could be, for other methods, it could be different functionality. It's not just about attributes. So in order to avoid defining the same attributes here in Shark, what you do is you define how you want Shark to have default values, but then you use super function to call init again and define and pass in these Shark arguments or these Shark values into the init method of fish. A bit difficult to explain this, but the point is super function lets you access parent class methods and parent class functionality if you have overwritten the method. And I'm talking about the same exact thing here. You may want to override one aspect of parent method with certain functionality, but then call the rest of the original parent method to finish the method. That's what's going on here. The functionality that we are overriding is default values for Shark. If you go into the fish, last name is fish, skeleton is bone, eyelid is false, but for the Shark we want different values. So that's the change that we're doing. But to reuse these attributes, what we do is we use the super function called the execution of fish class. So that's essentially the reason why you would want to use super function. And this is super useful when you're working with multiple classes and doing inheritance. A bit more about super function, what it does exactly. It returns a temporary object to help you access its methods, like the parent methods. And the purpose is to avoid using base class name explicitly. So if we go back to Shark, I could technically do this. I could technically do this. And this would be the same thing as using super function. But it's just not the Pythonic way. The Pythonic way is to use super function. So you might ask, why would I need to use super function if I have this fish available and it makes more sense and it's more readable to me? Why would I not be able to use just fish like this? Why do I need to remember the super function? There are a couple of reasons why super would be a better approach. Imagine you have a large code base, you have a large project, and you're using name fish explicitly all over the place. Let's say you need to override a lot of methods and you're using fish all over the place. And your project grows, and over time you realize that you need to rename your class fish. Let's say you would rename it to animal. Now, if you've been using fish everywhere and using fish to extend the functionality, you have to rename all the places where you're using fish. So that's one reason. Super just works the same way, even if you rename the parent class. Of course, you wouldn't have to do the change here, but imagine if you've been using this type of class method extension all over the place, you would have many places where you could just use simply super instead of using this fish. So let's take a look at another example with super function. Let's talk about this code. So what do we have here? We have the parent class grade with some init, with score, with calculate grade methods, and then we have a weighted grade. So this is the original way how we would calculate the grade, and this is the modified way how we would calculate the grade. And there could be, in theory, there could be as many as possible ways to calculate the grade based on the teacher or whatever. The main point is that this is the child class and this is the parent class. So what happens in a child class? Well, if this is a weighted grade, we want to add a new attribute, weight. So that's how we extend the original functionality of the grade class. We define a new init method, which is like overriding the original one, but we're calling also the original one to define a score attribute, which is already defined here. Not doing the same thing, like not copy pasting it here, but we are reusing what's already available in a grade class, and then we are adding a new attribute which is only relevant to this weighted grade class. Cool, so that's done. The next thing is, well, how we would calculate this weighted grade. Well, obviously we want to reuse the existing functionality in a grade class, so we are going to use super function. So the difference here is that, let's say for some reason the student has been doing great work in other areas of his class or whatever. For some reason he has the bonus points. And how would you calculate the grade for the student with bonus points? You would use weighted score. And basically the whole idea is that if the student has been doing great work in other areas and he has a good weight score, like weight here, he would automatically get a better grade. So let's take a look at how this would work. So by default, without the weight score, the student would get B. If we would run this code also, we would see that. So by default, the student would get grade B. But let's assume student has been doing great work in other areas of the class, been helping other students and so on and so forth, and he has the weight score of 1.3, he should get a weighted grade, which is automatically an A. So that's closer to a real situation. Obviously, this is just an example with student grades and so on and so forth, but this is what happens usually when you're trying to extend original functionality. You can still use functionality from the parent class, but you can extend it by overriding the original method, calculate grade, using the original method to get the result, but still making some adjustments based on the additional attributes or info of the child class. So the final part that we have to discuss is multiple inheritances. So this is a way for class inheriting attributes and methods from more than just one parent class. This is sometimes useful and reduces the amount of copy-pasted code. Obviously, that's what we are going for. We want to use or reuse existing code. But if this is not used properly, this can introduce certain amount of complexity that's just not benefiting you as a developer and doesn't give any benefit to the program. So you have to be careful with doing multiple inheritance. The best way how I could explain this to you, how does that work, is by doing a Python example with a very simple approach. So let's take this previous example and let's add extra class here and let's talk about that. So you can simply copy paste this example in PyCharm. So what do we have here? We have the grade class with calculate grade method. So we have the extra class with a very simple point method, extra points. So for simplicity, let's assume that this is very simple class, and generally what we want to do is just combine them into a single child class weighted grade, which would be grade and extra class together. So obviously we follow the same principles as before. We have init method, we override, we use super to use the init method from here and define score attribute in this class. But then on top of that we add the weight attribute. That's all and good. But then in calculate grade, what we can do is we can also access extra points method from extra class. So obviously we want to include that into the weighted score and calculate weighted score, or calculate the grade of the student based on the weighted score. That's including all the parts, grade, extra, and so on and so forth. So basically what we can do is we can use the extra points and we can define the grade for a student based on all of the points together. Or if the student doesn't reach more than 100 points, we can fall back to the original functionality, which is calculate grade, which comes from the grade class. And if we would execute all of this, you would see that by default, the student would get grade B. And if we assume that the student has weight 1.1, he would get A. We could also extend the functionality of extra class, add some more things to it, adjust it, and come up with different ways how students' grade could be increased based on the extra points. But this is like fairly simple example for you to just understand how multiple inheritances work. And this is useful if you want to build your code in a way that it's separated between classes. You don't want to keep all the functionality in one class. A lot of times you want to separate functionality between classes to make your code be more readable and more understandable for everyone. Or for example, certain functionality, like for example extra calculation, could be used outside of the grade class somewhere else. If this would be a project about student grades and so on and so forth. This is plenty of information. This is plenty of examples. This should give you a lot of details, a lot of examples of how to work with classes, how to work with class inheritance. If you have any questions, let me know, but just don't stress it too much if you don't understand this yet. If you feel like you're coming closer to the situation where you have to learn more about class inheritance, you will feel this point. Just know that you can come back to this video and learn about them here.